Okay, so here's the video on lesson 26, constructing polynomials from graphs. You'll remember from the beginning of the handout that there are a multitude, there are like 8 or 9 things that we want to do to describe each one of these graphs. So I'm going to go through them one at a time. This is the list that I'm referring to when I'm speaking and I'm answering different questions. These are the questions that I'm answering, A through I. I'm just going to be answering them about question number 4 because I think it's a good example and it lets me talk about a couple things that I think need to be reminded or reiterated. Okay, so first question, what degree polynomial would best fit the function? What degree polynomial would best fit? So when we're talking about degree, it can be related to the number of roots, which is 1, 2, 3, 4 roots, okay? Or it can be one more than the turning points. So there's 1 turning point, 2 turning points, 3 turning points. So either way, it seems to suggest that the degree is going to be 4. Okay? So the degree is going to be 4. I'll give you little explanations too. So this is question number 4. A. Degree 4, because there are 4 roots, and also because it's one more than the 3 turning points. And that's especially important. Okay, part B says label a point that appears to be a relative maximum. So relative maximum is like the top of a hill, so this is the point that we're talking about for B. Part C says labeled a relative minimum. So this is a relative minimum, and so is this. It's a valley, right? So we call the minimums valleys. It's like the bottom of a ravine or a valley if we're talking like topographically. So it's the bottom here. Okay. Now part D, is this graph a function or a relation? Well, if I draw a vertical line through it, it only hits in one point no matter where I draw this line. Okay, 1 point, 1 point, 1 point, 1 point, 1 point. So since it passes the vertical line test, it's a function. If you want to learn more about the vertical line test, just Google it. Part E. Describe the end behavior of this function. The end behavior. So as we go to the right, this function goes up. As we go to the right, the function goes up. So that means as x approaches infinity, f of x approaches infinity. As it goes infinitely to the right, which is x going to infinity, that's what it means along the x-axis, it goes up, which is towards y equals infinity. And just remember that f of x means y. Now let's look at the graph again. As we go to the left, which is negative infinity, it goes up as well. So as x goes to negative infinity, just left, y, for f of x, goes to positive infinity again. So that's the end behavior. Parts F and G are what is the domain and what is the range. So the domain is asking for what x values is this function represented. Basically, what part of the x-axis, right, this infinite horizontal line, what part of this is covered by the function? The function goes infinitely to the left and infinitely to the right. So it's all covered. So the domain, depending on how you learned this, sorry, it's part F, the domain could be from negative infinity to infinity, but the way that I like to write it is all real numbers, or you can just write it as the all real numbers symbol, which is the R with the double vertical. Okay, now part G. What is the range? So what we're asking is, what parts of the y-axis is this function on? Well, it goes up forever, right? It goes up forever over here, and it goes up forever over here. So it definitely goes to infinity. But does it go down to infinity? It doesn't. The function never goes below here. So the y-axis is not completely covered by the function. It's only covered from negative 500 on upward. So we're going to say for the range, for G, we're going to say that the range is from negative 500 to infinity. Now, H is asking for the roots. The roots of this function are relatively easy to see. They're just the points where it intersects. I'm erasing my minimum. Oh, I erased two minimums. Okay, so here are the roots. They are at negative 10, negative 5, negative 1, and 4. Negative 10, negative 5, negative 1, and 4. And if I want to make this into a function for part I, what I have to do is I have to reverse t-chart it. I've got 4 roots, so make sure I got 4 spaces. Negative 10 is here, negative 5 is here, negative 1 is here, and 4 is here. Essentially what I'm saying is we have 4 separate bubbles or sets of parentheses that these roots came out of. Now you might be good enough to just look at this and say, oh, this is x plus 10. Or you might have to do it like this. It depends on which one makes more sense to you. If I say that x equals negative 5 is one of the roots, I can say plus 5 on both sides, and I get x plus 5 equals 0. That is what goes inside the bubble, x plus 5. For the minus 1, I get x plus 1, and for the 4, I get x minus 4. So the function can be written as f of x or y equals x plus 10, x plus 5, x plus 1, and x minus 4. This is factored form, but this handout doesn't specify you have to use standard, so this is fine. Good luck with the homework. See you tomorrow.